Welcome to our last session of the day, folks. Before the networking and before we all take a little break from the Canadian Space Summit, our last session is last session is the role of Earth observation satellite imagery in monitoring the impacts of COVID-19. The session is really a prime topic for this entire year. So, and the session is organized and hosted by Dr. Tanya Harrison, who's worked as a scientist and in mission operations on multiple NASA Mars mission over the past 12 years. She holds a PhD in geology from University of Western Ontario, a master's in earth and environmental science from Wesleyan University, and a bachelor's of science in astronomy and physics from the University of Washington. Currently, she's a director of science strategy for the federal arm of Planet Labs, which is a very, very cool title. Tanya is also an advocate for accessibility in STEM. And obviously, as I follow her, you can find her tweeting about Red Planet and her experiences being hashtag disabled in STEM as on at Tanya of Mars, which I'll share shortly. So Tanya, I want to give the floor to you. And thank you so much for being here, and thank you so much for being able to share your insights with the entire community.
Great, thanks so much for having me. Let me share my screen here. Okay, is that working?
Yep, we can see it.
Great. So I'm Dr. Tanya Harrison, and today I'm going to talk a little bit about how imagery from the Planet Labs constellation of satellites has been used to monitor the impacts of COVID-19 on our planet. You might not think of satellites when you think of looking at the effects of a pandemic. And while in the case of something like COVID, where this is not a disease that is, say, waterborne, so we could monitor things like mosquito habitats, for example, to look at places where you might be getting other kinds of diseases. We can't monitor COVID directly with satellites, but we can see how the shutdowns from COVID have impacted our planet as a whole. And we have some really striking examples of that have been visible from Earth orbit. Just to give you a little bit of background, so my title is Director of Science Strategy, and when the CSS folks approached me, they wanted to know what that was. I provide science and technical support for researchers using planet imagery. I used to be a researcher at Arizona State University after I left the University of Western Ontario, using planet imagery through a program they had called the Science Ambassadors Program, where they gave data to scientists to put it through its paces, to publish it and promote Planet at conferences. And now we have a full-fledged education and research program where anybody that is a student or faculty member at a degree-granting university can apply for free data access to Planet, as well as some other tiers of access if you need way more data. And we also have an agreement with NASA, which is most of my job at the federal arm of Planet Labs, which is working with NASA researchers to help them figure out how to use planet imagery in their workflows and in their research for everything from water quality monitoring to air pollution to glaciers. You name it, somebody is probably using planet imagery to research it, which is really amazing. It means that I get to look at so many different things every single day. I also provide input to Planet from the research community at large in terms of things that they might want to see from image specs, new products, if they need more documentation on anything that we may not have on our website currently, stuff like that. And then I look at strategic science partnerships for research and development. So are there any specific institutions or researchers that we should be working with to help improve any of our products or image quality or influence the design of future satellites? Because we are an agile aerospace company, we have the ability to build 40 satellites a week in our facility in San Francisco if we wanted to. We don't build that many because we don't have that many satellites in orbit. Our constellation right now is 150 3U CubeSats, which are the doves, and then 21 SkySat satellites, which are about the size of a dishwasher. But because of that, we can rapidly iterate on designs and change anything from the software to the sensors to the design of the telescope itself, which gives us a lot of flexibility in terms of what we want to do in the future. So how can satellite imagery help during a pandemic like COVID-19? When millions of people began sheltering in place earlier this year, a lot of government agencies came to Planet asking how we could help with satellite imagery. So today I'll highlight some of the examples of changes that we saw on the planet with our imagery, and then some of the research that's actually already been published within 2020 on some of these impacts from COVID on our environment. So first, we'll focus in on Wuhan, China to see the start of their shelter-in-place orders. So this is sort of a more typical day in Wuhan in middle of January 2020 from one of our SkySat satellites. You can see tons of cars on the road here, lots of cars in parking lots all around. And then we took another image 2 weeks later on January 28th, and there are no cars anywhere. So you can really see the difference in the shutdown between January 12th and January 28th. This was very quick. This is another example from Wuhan where you can see cars on this bridge here and a lot of cars in some of the parking lots around here, on the road here. And then if we look at it again on the 28th, completely empty. So we got a lot of images like this around the world where after you had certain shutdown periods, really things just started to look like ghost towns everywhere. Sorry, there's a little bit of a lag when I'm changing the slides on my end. You probably saw a lot of news stories coming out about how the shutdowns impacted air quality around the world. These are some maps from National Geographic showing the change in NO2 pollution in the atmosphere, increases and decreases around the world between January and March of 2020 versus 2019. So all of the places where you see blue on this map are places where NO2 decreased over time, and the purple areas are places where you saw an increase. So over China in particular, especially over the region where we see Wuhan and over South Korea, all over India, you had these massive decreases in NO2 concentration as you had things like lots of factories shutting down, lots of cars being taken off the road compared to 2019. And then you saw some places where there was actually increases in nitrogen dioxide, like Eastern European countries. I'm not sure what the change here was attributed to. This might have been before a lot of Europe decided to shut down because this was still March at the time. And a lot of the Asian countries actually shut down earlier than other parts of the world. So you saw these changes much more rapidly. Now, the satellites that were used to look at this NO2 concentration, these are things that are actually looking at aerosol concentrations sort of directly. And we can't do that with optical satellites, but we can use things as proxies to look at that. So this is an example of Beijing, China, with an image from near the start of 2020 on the left, and then in mid-March of 2020 on the right. This is the exact same spot. You can make out some of the same features on the ground here, but you can see that the smog is completely gone. And so some researchers were actually able to look at this area and decided to figure out, is there a way that we could use these optical imaging satellites to look at air quality on the ground? So this paper by Zheng et al., which came out this year, was looking specifically at what we call PM 2.5, particulate matter smaller than 2.5 microns. This has extreme health hazards because if you inhale it, it can cause a lot of damage over time to your respiratory system. And so this is why in a lot of highly polluted areas like China, even before the pandemic, you saw a lot of people wearing face masks. These weren't because of pandemics, this was because of air pollution, which is quite obvious in the satellite image I saw before. I'm sure all of you are very familiar with pollution problems in places like China and India, where we have a lot of cars and a lot of industrial production going on. So usually measuring this PM 2.5 from orbit has required the use of something called an aerosol retrieval product. But these are usually really coarse resolution, so greater than a kilometer on the ground. And the estimates that you get of PM 2.5 from these have really large uncertainties due to a number of assumptions that are baked into the estimation algorithms that they use this data in. So this research group led by Tongshu Zhen at Duke University decided to try and make a more accurate and a more cost-effective approach to mapping out ground level particulate matter so that the epidemiological effects of exposure to this stuff could be better quantified. His team used machine learning through convolutional neural networks, or CNNs, to identify features on the ground that are visible in the PlanetScope imagery. So the PlanetScope is our Dove constellation, such as buildings and roads near 35 separate air quality monitoring stations in Beijing over 2017 to 2019. So looking at the images, if we go back one slide, looking at how, say, the specific road changed in appearance over time, comparing that to the coincident measurements of air quality monitoring from these stations on the ground in Beijing. They then analyzed the changes in color of these features, the buildings and the road over time, relative to what the PM 2.5 levels were measured on the ground. And then they were able to feed this into something called a random forest regressor, which takes in the appearance in the satellite images changing over time and the data from the air quality monitoring stations and weather information from meteorological stations like temperature, relative humidity, wind speed, air pressure from Weather Underground. And from this, they were able to create these 200-meter resolution estimates on a near daily basis of these PM 2.5 levels over Beijing. They got some really impressive results in this area. Their error was about 23%. And they had trained their model on the images of Beijing, so the changes that they could see on the surface there. They then took these algorithms and applied them to Shanghai, where they didn't want to go through the effort of retraining the models with new imagery. They wanted to see how accurate were the results if you take images that are similar to what you would see in one place and apply them to another. So obviously looking at buildings and roads in a place like Shanghai is going to look very similar to buildings and roads in a city like Beijing. They're similarly built up cities. And they were able to take that and apply it without retraining their algorithms. And the results over Shanghai, purely from the PlanetScope imagery, taking that and then comparing it to the air quality monitoring results on the ground, they only had an error of about 18%. So Zhang's team thinks that they could now take this algorithm and apply it to any similarly built up area and get relatively accurate measurements on a near daily basis at this 200-meter resolution of the air quality, which is really important because air quality monitoring stations are extremely expensive to build and maintain. In Beijing, they gave numbers of about $1 million a year. And you might have cities where they don't have a lot of them or they don't have them at all. And then eventually you could take these models and train them over areas using new input PlanetScope images to try to make these maps over areas that are not as built up as a place like Beijing. Another example that you may have seen in the media was the changes in the canals of Venice over time from the pandemic. So here is an animation of our PlanetScope, the Dove images between January and March of this year. There are some changes in color just because of the atmosphere. Obviously, how cloudy or hazy it is over time affects the color in the images. But you can see things like a very stark drop off once you hit March and April in the color and some of the features that you can see. These dark areas, these are actually things that you're looking at underneath the water. If we zoom in, this is a view of SkySat taken on October 29th of last year. Lots of boats, a lot of the sort of white roughness that you can see in this image, that's actually waves and turbidity caused by these boats going through the canals. So there's a ton of boats all throughout Venice. And then we compare that to March of 2020, right when Venice shut down. Huge decrease in the number of boats that you can see, massive decrease in the appearance of the water. If we look before versus after, it looks completely different in terms of color because you've taken away a lot of the turbidity with removing the boats, which in turn reduces the number of waves and the amount of suspended sediment that's been churned up by the boats moving around throughout the canals. This is a view on February 28th of this year. If we zoom out to see all of Venice, compared to the middle of the middle of March, early in lockdown. So you can again see the decrease in the number of boats. All of these little streak things here, these are boats that are moving. And you can also see some of these areas darkening here. So we're actually getting a better view under the water because you've removed a lot of the turbidity and some of that suspended sediment. And so this paper that just came out, I believe this was last month, from Niraman Jajidi et al. In remote sensing, they were actually able to look at the total suspended material using planet imagery. And this is a comparison from January and February of the amount of total suspended material. So that's stuff that's been kicked up by the boats mostly as they're driving around, compared to before lockdown and then during lockdown in middle March and early April. And there's quite a significant drop off. They also did counts of boats, the number of ships in the areas that they were specifically looking at around Venice before lockdown. They had like 60 to 70 boats in each image, compared to 9 boats in the images they analyzed during the lockdown. So they could directly see that the reduction of boat traffic led to a reduction in the amount of total suspended material during the lockdown. And they were able to then take advantage of these relatively clear water images during lockdown to look at the bathymetry, which is like the topography underneath the water around Venice. It's really difficult to do that in areas where the water is turbid because the light that's coming in from the sun is just reflecting all over the place, kind of like if you're looking at the water at the beach and it's like blinding you because the sun is reflecting into your eyes. That's what's happening when we have turbid water. It's just reflecting a bunch of light back into the satellite. But when water is really calm, we can see through it really well and start to do analysis of what is under the water. So from this, they were able to make some algorithms you could apply to not just Venice, but other areas where you have calm water to get an idea of some of the bathymetry in these shallow water areas. So down to about 10 to 15 meters is usually how deep you can get looking at this optical imagery when you're trying to look under the water. They did some correlations of looking at these bathymetric calculations before the lockdown. So the top row here is before, and the bottom row here is some of these measurements after. So comparing the stuff they got from satellites to data they had on the ground. And for graph nerds here, you can see that there's a much better correlation in the images taken during lockdown when the water was less turbid compared to the images taken before lockdown. And from this, the authors of the study noted that the high spatial resolution in combination with that daily revisit rate of the Planetscope constellation, which is imaging the entire planet every single day at this 3-meter resolution, potentially enables advances in near real-time monitoring of inland and coastal aquatic ecosystems, which is really, really fantastic because these places are constantly changing due to both weather, climate change, and human impacts. And having such a good time record of this is really beneficial for us to understand the small scale changes that are building up toward the large scale effects. Getting a little bit closer to home, these are some views of Central Park taken in late March of this year and then early April, where at this point the epicenter of the COVID outbreak had shifted to North America. And this is an area where a temporary hospital was set up in Central Park in Manhattan. Pretty soon after this, the rest of the US started to shut down. We could see the effects in places like San Francisco. This is the Bay Bridge toll plaza on the Oakland side, heading over towards San Francisco. Before the lockdown in middle of February, these red, green, blue streaks here are cars. The cars are actually moving fast enough that the different frames of the satellite, red, green, blue, are imaging slower than the cars are moving. So you can see the cars as little streaks. And then these are all the parked cars at the toll plaza. And this is what toll plaza looked like in the middle of lockdown. So quite a huge change in the amount of cars backed up at the toll plaza to get out of Oakland. A lot of planes were grounded during this time, obviously. So this is March 4th at an airport in Victorville, California, compared to March 25th. So you can see that they ended up with a bunch of planes parked on the runways here. So again, if we go before and after, you'll see a lot of planes cropping up over here in this parked area as well, before and after this. Here, this is a beach in Florida. You can see the number of people here gathered on the beach and some boats offshore. Compared to early in the shutdowns, there's still some people on the beach, but quite a huge difference compared to before. This is a view of Disney World early this year with the SkySat satellites. You could see cars in the parking lot here. And if we switch to March 18th, right when the lockdown started, the cars are essentially gone, other than a few that are left here. So again, getting this sort of ghost town effect of seeing where everything is shut down. Now, Planet is obviously not the only data set that has managed to capture the effects of COVID. This is just one that I'm most familiar with since I work for Planet. But NASA, the European Space Agency, and JAXA, the Japanese aerospace organization, they have all come together along with data from commercial satellite providers like Planet and Digital Globe, or Maxar, to create this Earth observing dashboard where you can go and look at the effects of COVID on places all around the world. You can look at air quality monitoring. They've done some stuff with Planet images in this dashboard, specifically to look at boats, airplanes, and I think they've done some car counting in here as well. So if you go to eodashboard.org, you can actually go through here and start exploring some of the impacts of COVID on wherever you want to look in the world. And I'm not sure if the audio will play from this. So I'm going to hit play. If you can't hear it, let me know in the chat. Oh, maybe this version doesn't have any audio. Sorry about that. This is just a demo of some of the things that you can see inside the Earth observing dashboard. So if you look around, you can navigate through different maps. You can highlight, you can go in and click on some of the highlighted areas that NASA has analyzed in terms of this. So here's shipping activity in Long Island Sound, for example. So there's a lot of great stuff that you can see in the Earth observing dashboard. So I highly suggest you can go check it out and play around. So if we look specifically on Venice, we'll go back to the early example that I showed before, we could visually see the difference in boat traffic and water turbidity, but in the EO dashboard, using information from not just PlanetScope, but several different satellite sensors, we can actually turn these observations into quantitative observations. So here, this is combined with a few different satellites like Sentinel-3A, which is operated by the European Space Agency, and the NASA Aqua Modus satellite to look at how the water quality has changed over time. And then looking at Beijing, this is some of the quantitative information over Beijing in terms of air quality, incorporating information from different satellites. Here it highlights, sorry, whenever I move my cursor over the screen, it brings up my bar there. You can see at the bottom here, it says data shown here is from the tropospheric monitoring instrument from Sentinel-5. If you scroll down, it will list all the different satellites that are providing information to the view that you can see at each time. Some of this, we try to capture information about disasters anywhere in the world through something called Planet Rapid Response, where we actually work to get data out for free when it comes to responding to disasters around the world. So looking at stuff separate from COVID, if you're interested in looking at planet imagery to look at anything that is impacting human health and life around the world, you can go to planet.com/disaster data. And we have disaster data sets available on there that you can go through anytime that something called the International Disaster Charter has been activated. We will release all of the data that we have for that particular area. So the ones that are listed here, I took the screenshot a few days ago. These are the currently available data sets for disasters that have occurred around the world. So I encourage you to explore the EO dashboard to learn more about how COVID-19 is impacting our planet and people around the world, and see how satellite imagery has been helping in the analysis of the impact of this on our environment, and giving us the opportunity to see how humans really are impacting our planet on a day-to-day basis in a very significant way. Um, it's unfortunate that it has taken a global pandemic to help highlight some of this, but it's given us the chance to learn from some of this experience. And so I highly suggest taking a look to see what all we can learn from the different data sets that we've collected during these lockdowns and looking at the impacts of this pandemic. And with that, if there are any questions, I
And of
guess.
course, there are lots of questions for you, Tanya, as always. Um, so we'll start off with the most favorite questions. I just want to remind everybody that please go and upvote the questions that you would like to see, you like to be asked, and shared. So the first question is first. I will pull up my screen here just so everybody can have a look at that. What options are there for citizens, scientists, non-students, researchers to get access to imagery data?
In terms of planet imagery, the only real option. Well, there's the disaster data program I was just mentioning. If you want to work on stuff specifically related to current disasters, there's also data on there for past disasters you can play with. But we also have a program called the oh gosh, we just launched it. There's basically a developers program where you can get a little bit of data to play with if you're familiar with how to use things like APIs. If you're interested in more information on that, send me an email and I can get some more information. I don't remember all the specifics because we literally just launched it. But those are the only two programs that we really have right now for non-students.
Excellent.
Oh,
And
actually,
yeah,
if you the tab you just
go on.
had open, the second link on there was the
Oh,
developer program.
it's
Yeah,
this one.
announcing Planet's developer trial program. Oh, sorry, I guess it's the first link.
Oh, there
Yeah,
you go.
announcing developer trial. Yeah, so Google this. Sarah Safavi listed here. She's the one that's in charge of it. She is awesome. And this is a great way for developer folks to get a chance to play around with some of the data and test the capabilities.
Excellent. I just posted the link. So enjoy those who asked that question. I hope you can be part of that program. Planet's excellent. I love it. So Jason asked, what about the M/LWIR optical bands directly image aerosol constituents? Maybe future products for Planet, or are the cameras too complex?
So a lot of those bands are available on some of the NASA and ESA satellites. We don't have them on the Planet satellites right now, mostly just because the doves are so small. They're literally about this big. And so we can't image anything in the like infrared and beyond. We've got a near infrared band, which is less than 900 nanometers. But anything beyond that, you start needing cryo coolers in your satellites. And so we would need to build bigger satellites for that to happen. Can't comment on what the future is for our satellites, but certainly more bands is something that we're always interested in so that we can get more data for more applications.
Yeah. So Mark asked, when the smog or cloud is clear, can Planet Lab zoom in to see details such as streets, pedestrians, or is there any restriction on the zoom, quote unquote, zoom in value?
So the data that we have from the Dove satellites is 3-meter resolution. So it's not enough to resolve individual people or cars or buildings. It's designed for what we call patterns of life. And that's the data set we have that images the whole landmass of the Earth every day. The SkySat satellites are 50 centimeter resolution. So those are the ones where I was showing like the examples of the parking lots and the bridges and things like that. That we can start to make out individual cars, but we can't necessarily identify, that's a Toyota Corolla, that's a Hyundai. So, and you can't really necessarily do that with a commercial data set just because there are limitations from the government in terms of the highest resolution that we are allowed to image at. When you get really high resolution, that's when you start getting into things like military spy satellites, and they don't want commercial companies to have that ability. So the 50 centimeter data which I was showing in a lot of those slides, is the highest resolution data that we have available.
Absolutely. And the last question for the day, in addition to gathering bathymetry data, was vertical transparency measured using Sechitisk or other methodologies? It's a very, very technical question.
Yeah, that I'm not sure since I was not part of the research. It's just an example that someone is doing in the community with our own data. So I apologize for that. But if I still have the link open, I had it open a minute ago. Let me see. Yes, here is a link to the paper on the Venice canals if you want to take a look at their methodology more closely.